All right, let's do an example problem here. So this is very similar to the one we did for a grouted wall. The difference is that we're going to use number 5 bars at 24 inches. It's still an 8-inch block. There's still the bars are spaced at 24 inches, which is a multiple of 8. Great. And I'm going to look at the chart with 2500 psi, grade 60 bar. One of the first things I should do is just go ahead and figure out if KD is less than the thickness of the wall. So this is kind of an extra step that we have to do. So D, we had a D last time, same with an 8-inch wall. It's going to be 7.625 divided by 2, which is 3.8125 inches. I'm going to need to find my K value. So this is different, an additional step. So steel over masonry is going to be 29 million over 900 times 2500, and I get an N value of 12.9. All right, I need rho as AS over BD. It's one number 5 bar every 24 inches. A number 5 bar is 0.31 inches squared. The B here is 24 inches, and D is the 3.8125 inches, and I get a rho value of 0.034. So if I then solve for, this is little k, it's this equation in rho squared plus 2 in rho square root minus in rho. If you plug all those values in, you get around 0.25. So K times D is equal to 0.95 inches. And the thickness of the flange for these blocks, we talked about this before, is 1.25. So KD is less than TF. Awesome, because it's not a T-beam, which means we can just do this the same way we always do, which is handy. So let's do that calculation. So you can go through and calculate M sub M, M sub S, so masonry, steel, see which one is smaller, so which one controls, or I can use the tables that we've been using, which I kind of like because it makes this a very quick problem. So for the tables, M is equal to big K sub F BD squared. I want to go in and find K. So go into my engineering handbook, and I happen to have the table pulled up for masonry, 2500 psi. You got to watch this. It's easy to grab the clay one accidentally, and you want to make sure your strength's the right one. So my rho value was my rho value was 0.0034. So here's 0.003.35. So it's just slightly inside of here. If I carry that up to the first one, looks like I get pretty close to 100. It's maybe 102 or something like that. Okay, so I go back and I do this calculation. So KF, we can say it's around 100. I'll let you guys decide how much you want to iterate there. After you get through the units, that's probably close enough, but I could do like 102. Or you can go back and actually interpolate. Let's erase this. This is from the last problem. I can go back and interpolate with my rho value and figure out exactly what it is. But that also will be around 100. All right, so moment equals K, 100, times B, 24 inches, D squared. I could look at a B of per foot, but I think it's a little clearer to do that moment. And then our moment is going to be per foot of wall, right? So per foot of wall, and I have a 2-foot wide slice right now. And so if I come through there, I'm going to get the equivalent, and you can divide by your 12s and here. Do this calculation, but I'm going to do all that division, and I will get 1.4 hip foot. So you need to convert to, you got to divide by 12 over here again. Right, and you'll get 1.4 kip foot per foot of wall. Okay, that's the capacity, the moment capacity. Okay, so short example. If you go do these calculations, it's not really all that much longer, a couple minutes, but with the tables, this goes very fast. All right, we'll pause and I'll do one of these design